Today our group will present on lighting scheme design in Engineer Auditorium of Faculty of Engineering. So first of all, I will introduce my group member. I'm Aifa, and we have Muhammad Farid, Muhammad Izzat Firdaus, and lastly Ahmad Faris. Okay, our main objective is to design the lighting scheme in Engineer Auditorium. Also, we provide guidance on the best way to integrate lighting solution into new development or into the existing development. The objective is to offer advice on reducing the negative impact of lighting scheme, and lastly, to provide guidance so that lighting scheme better respect to the surrounding. And so our methodology is, first we choose the area at Engineer Auditorium, Faculty of Engineering. Then we analyze the design of auditorium by checking the electrical components such as lamp, air conditioner, and also socket. Then we do the manual calculation to obtain the number of luminaire, power consumption, and overall cost of the lighting design. At the same time, we design and simulate the lighting scheme using dialog software to analyze the result. Dialog software usually commonly used by the engineers or building service engineer in the industry to show a proper visual design when lighting scheme is constructed. They can design, calculate, and also visualize light professionally. And lastly, we compare the result we obtain with the manual calculation. Lighting scheme can bring a range of benefits, such as reduce the fear of crime. It also can increase road safety. At the same time, can enhance community benefit arising from the greater use of facility. And lastly, can underpin economic activity. So in designing a basic lighting scheme, there are several factors that we need to consider. First, the sorts of activities that will be conducted or performed in that certain area or room. And also we have to consider the type of lighting used that will create a comfortable environment or surrounding. And also we need to consider the mood that need to be created in order to aid the appropriate visual environment. So we have four basic principles, lighting principle and term. First is light quantity. Light quantity, we should consider the illumination and also the lumens. For energy consumption, we should consider the efficiency of lighting to the energy consumed. Then we should consider the light quality. We have bad light, indifferent light, and also good lighting. Lastly, we have we should consider the lighting used, such as ambient, accent, and also task. The ambient lighting will provide overall illumination. The task lighting will perform specific tasks and should be bright enough to avoid eye damage. And also the accent lighting, which can add the drama to the room by creating visual interest, such as painting.
Hi. Okay. Today I will explain about the luminance and the room space for the auditorium. Before we jump to more deeply about the luminance that will cover inside the auditorium, first of all, we must know what is the lighting system that have been designed for this auditorium. So how do we want to know? We must get the layout for the auditorium. So basically, this is the front view of the auditorium. We need this we need this view because we want to find out what is the height between the luminaire and the workplace. So after we study about this place, this room, so the height is 6.84 meter. Next. So this is the floor plan for the auditorium. Basically, if we see from this picture, we know that the total width for the auditorium, including the stage and the what we call is audience, is total is 24 meter. So, however, in our study, we decide to find only the audience place, which is as our target area. Okay, so the total width that we consider only from this side until this side, which is 16 meter, and the length is only 19. If we total up is only 19.6 meter. Okay, next. So now I will conclude inside in this table, and this is the blueprint for our auditorium rooms, which is it will introduce how much lamp that will be used in that room. So the total lamp or the total luminaire that we use is 24 fluorescent, 15 bulb. Basically, this is a bulb. Okay. Then a six spotlight at here. Okay. So next. Alright. Yeah. To find out how much luminance that will be covered inside the auditorium, we must using one software that will be help us to find out that luminance. So this software is known as a Dilux. So after we design, basically we design based on the layout that I mentioned before. So it looks like almost same with the previous picture. Next. So this is the result after we design using the Dilux software. Basically, if you see this picture, you can realize and appreciate the lighting distribution that has been covered inside the picture, almost 500 lux, which is the standard for the hall rooms. So what we can say is the lighting system that already designed by the engineer is already perfect. However, next slide. However, we know we already studied about the cost that will contribute from that lighting system, which is we can consider more higher for the payment for the electric bill payment. So what we suggest is we try to redesign back the lighting system and how much the lamp that we need to use. So we just so during the redesign the lighting system, we suggest to only use two types of lamp, which is the fluorescent and the spotlight, which is more efficient rather than using the bulb, because we know with using bulb it have a higher power rate power. So besides that, to redesign this lighting system, we prefer to use a twin lamp, which is in one luminaire it have a two lamps. Okay, next slide. So this is this is the calculation for how we redesign the lighting system. So first of all, we must know about the room index to find out how much the utilization factor. Okay, so this SHR we got from the data sheet for the land itself. Okay, so yeah, after we got the room index, we can put inside this formula, which is to find out how much luminaire that we need use for that auditorium. Okay, so basically I'm use 500 lux as I mentioned before because of it is a standard for the hall. Okay, so at the end of the day we can say we only need to use 26 luminaire to cover all target area. Okay, so yeah, next slide. So after we redesign that, we can appreciate, we can improve our luminance by redesign the lighting system. So besides that, we also can reduce the cost for the lighting system and the bill. So I believe my friend will explain more about the costing and how we calculate that costing. So I think I will pass my presentation to Izzat Firdaus.
Okay, Assalamualaikum and very good evening. My name is Muhammad Izzat Firdaus. I will explain about cost and energy consumptions. Okay, in our research and our findings, we found that in the engineer auditorium at the Faculty of Engineering UPM, we found that there are three types of luminaire exist in that auditorium. Okay, for the first one, for the kind of bulbs models, each general characteristic that which is important in our research. Okay. First one we need to know is the dimension itself, because the dimension is over 340 or 140 times 4x 5 millimeter, and its weight about 6.8 kilograms. Okay, for the technical characteristic that will be considered in our calculation and our consideration in our choosing for our luminaire. Okay, for the first one, for luminaire efficiency. Okay, let us know about the luminaire efficiency. Okay, luminaire efficiency in the short terms is the percentage of light outputs produced by the lamps that are in turn emitted by the luminaire. Okay, as you can see, the luminaire efficiency is about 108 lumens per watt. Okay, and then luminous flux. Okay, let us see what the luminous flux stands for. Okay, luminous flux is the quantity of the energy of the light emitted per second in all directions. Okay, as you can see, the unit is lumens. For this kind of luminaire is 6047 lumens. Okay, for its maintenance category is categorized for the C, which is closed stop reflector. Next one. Okay, this is our second luminaire model, which is fluorescent shapes. There is its model is quite long. Okay, next. Okay, for its technical characteristic. Okay, its luminous flux is 6020 lumens. Okay, which is higher than our bulbs. Okay, then luminaire efficiency is 128 lumen per watt, and then it emits its temperature around 4000 Kelvin. And then the most important one is luminaire input is 47 volts, and its maintenance category is different of our bulbs. It's categorized in the category which is enclosed IP2X. Next one. Okay, this is our last model that we found in our auditorium, which is in spotlight model. This is model. It's a visual LED 2600. Next. Okay, for this kind of spotlight lamps, okay, for its technical characteristics, for luminous flux, it emits 2555 lumens, and then its luminaire efficiency is 91 lumen per watt, and then it emits the power around 28.2 watt. And then for this kind of spotlight, it distributes light flux around 20 degrees. Next one. Okay, this is our comparison between our lighting scheme. As you can see, as I said before about its luminous flux and its voltage. In terms of the price, as we can see, LED bulb is quite cheap because it just costs around 12 ringgit only, and the most highest price is the, of course, spotlight LED, which is 120 ringgit. Okay, this is our estimate consumed power used by our electrical appliance in our auditorium. Include our luminaire, we found this before, and includes with air conditioner and emergency lights and the socket 13 ampere. Okay, as you can see, our estimate consumed power is around, we calculate for it maximum use for our auditorium, which is 12 hours. This is for maximum. Okay, for next one, for LED bulb, is use 672 watt hour, and then for fluorescent LED we use 564 watt hour, and for the spotlight is quite low because it's emit consume power around 338.4 watt hour. And then for our conditioner, air conditioner is quite high because it's consume around 1400 watt hour, and then our emergency lights only 10 watt hour, and then lastly for our socket 30 amps we consume around 250 watt hour. So this is our calculation about how we will calculate about our electric bill per month for our electrical appliance, which is total kilowatt hour use multiplied by the number of days per month, which is 30 we assuming, and then lastly for we time with cost per kilowatt hour. So in the Malaysia tariff we use 0.21x ringgit per kilometer watt hour. Next. Okay, this is our summary about our calculations, which is the existing electrical appliance used in the auditorium. For the first one, for the LED bulb, which is its quantity is around 21. Quantity is cost around 92.29, and then for our LED fluorescent, which is have around 36, which cost 132.79. Okay, for the spotlight, which is used around the 6, will cost around the 22.13. Okay, for our socket, will just cost around 1 ringgit, 0.655. Our conditioner, 36.76. For our total existing electrical appliance used in our auditorium, around 285.61 ringgit per month. Okay. Next one. Okay. So after we calculate for the different type of the for cost that we redesign our luminaires in our auditorium, this is the result, which is we use the DX of the LED bulbs, and we use 6. We still use for the 6 spotlights. This is our its core, which is our we maintain for the socket and the air conditioner, and now it's only cost around 270 cents. So we can cut off some kind of the bills for a month. That's all. Okay, I will pass to my friends. Faris.
So hello, Assalamualaikum. I'm Ahmad Faris. I will be presenting about lighting design considerations. Okay, so on the three above, cost, energy consumption, luminance, and room surface have been discussed by my friends Rafiq, Farid, and Izzat. But I will discuss about compliance to the standards. Okay, the first, for the compliance to standard, we can see the first one is energy efficient design. Energy efficient design refers to saving the not saving but reducing the power use. Also, as power use is reduced, we can save the money used for the power. And the second one is accessibility for servicing. As in the auditorium, to service the lights, the lights are placed very high in the ceiling. So accessibility for servicing, we can to design the lighting, we need to place the places at the accessible places, so that the maintenance crew can access the lightings with ease and comfort. Okay, like you can see here, careful consideration must be taken in the design of lighting systems regarding servicing of the fixtures and replacement of tubes or bulbs. And discussion is also needed with building operation staff, as we need to know the limits of the equipment, like we can whether we can tinker with not, or whether it is unstable or fragile or not. Okay, the third is lighting features. Lighting fixtures and associated fittings should always be of standard commercial design. This means like we always need to use the normal design, the in the market design, not our like custom, because this also affects in the accessibility for servicing. The maintenance crew will need to order new parts and new lighting. So for custom design fixtures, the maintenance will be hard, as the maintenance crew doesn't know how to handle them. Okay, light sources. Generally, interior lighting should be fluorescent. Downlight should be compact fluorescent. High lighting should be high intensity discharge, which is this one. HID can also be an appropriate source for indirect lighting of high spaces. We can see here, this is a HID, which is often used in the museums or like opera to create mood in for like IFA display area. This is used to enhance the paintings quality, like because it has the mood lighting. Okay. Dimming can also be accomplished with incandescent, fluorescent, or HID fixtures. Incandescent lighting should be used sparingly, as too much will annoy the consumers, the audience, and is appropriate where special architectural effects are desired, such as the museum or the opera. Next is the implement. Can you before? One more. I forgot to say about the lighting features. As Farid explained earlier, we have reduced the types of box used, so the lighting types used from 3 to 2, as we have removed the bulb lighting. This can be related with this point, because as we only use two kinds of lighting, the cost will be much cheaper, because the lighting is ordered in bulk. So as if we order in bulk, the company often give promotions and whatnot, and also it also is maintenance, as there are only two kinds of lighting that we need to service. Okay, next to the one. Okay. This is the implementation of the latest technologies on lighting. The Internet of Things is common now, because with our phones, with our smartphones and the devices like smartwatch, we can easily access any lighting with the smartphone or the app in the smartphone. Okay, the second one is the built-in light, built-in module with LEDs. And the LEDs don't have to be replaced often. This is the point, because modern lighting now have an built-in module, the LED, and also the external interchangeable module, as maybe there are parts failure in the external module. So the LED, the built-in light will be used instead of the external module. Okay. This is often used in mobile devices. As we read, no artificial lighting is needed. This is explained as a backlight device. Okay, the third one is healthy lighting. With modern research now, light influences how productive we are at work, how well we learn, and how quickly we recover from illness. Like you can see in hospitals, they use lighting that in bright lighting, which means healthy lighting, to promote healthy consciousness on the patients, so that they can recover better. Okay, this is another point. They say, it is gradually getting easier and cheaper for lighting manufacturers to put this knowledge. So this is commonly implemented in the latest technologies. Next. Okay, new power technologies. Drivers can convert incoming AC power to the proper DC voltage and regulate the current flowing through the LED during operation. This is an example of a driver. Okay. The driver converts AC power to low voltage DC power required by the LEDs and protects the LEDs from the line voltage fluctuations. This is very important since it acts as a converter, a regulator, and maybe both of them. This is very commonly implemented now. And the last one is wireless lighting, which is in the US, lightings are common now as they use lighting that need no wires. And to connect them with the remote control, we use maybe IR, maybe Bluetooth, maybe any kind of wireless communication, as it is very as no wires is needed, and Bluetooth technology is wireless local area network technology is very cheap now. This replaces the need of wires. Okay. Next. Okay, that's all for my part.
Okay, to summarize our presentation today, I would like to conclude that the factor that need to be taken into account in order to design a better lighting scheme in engineer auditorium is we have to consider the activity that we perform in that area, the suitable lighting to create a comfortable environment, and the type of color ceiling and wall, and lastly the decorative around the room. All these factors are important as it can give better environment as well as can save the energy. So the new design of lighting system in this auditorium using two types of luminaire, which is fluorescent and spotlight. It will give benefit to UPM because it can reduce the maintenance cost. Okay, this design successfully reduced the electrical bill from RM285.61 to RM270. This design also already improved the luminance for this room. So that's all for our presentation today. Thank you.